We are live. Hi everyone, welcome back to Geeks for Geeks practice. Today in this video we'll be discussing the Geeks for Geeks problem of the day for 7th of January, and the name of the problem is post-order traversal, and you have to do this iteratively. So consider giving me a +1 in the chat if my voice is clearly audible to everyone and my screen is visible, and then we'll start with this problem, right? You can just give me a +1 in the chat if my voice is clearly audible and the screen is visible. Also, you can like the video and then we'll start with this video. Right? So in this particular problem, what you have to do is you will be given a binary tree, and what you have to do is you have to print the post order traversal for that given binary tree without using recursion, right? That is without calling a DFS function exclusively. You have to do this. So you have to do this in an iterative manner. So all of you can give me a +1 in the chat if my voice is clearly audible to everyone and the screen is visible, so that we can start as soon as possible. Right, I'll be waiting for you all. So this problem previously has been asked in organizations like Microsoft, right? Organizations like Microsoft and Amazon have asked this particular question. What this question particularly says is that you will be given a particular binary tree, right? You will be given a binary tree, and what you have to do is with that particular binary tree, you have to print the post order traversal for that particular binary tree, and you have to do this iteratively, right? You have to do this in an iterative manner and not using the recursive manner, right? Please like the video and give me a +1 in the chat if my voice is clearly audible to everyone, if the screen is visible, so that we can start with this problem as early as possible, right? Now let's say if you have been given like 1, 2, then 3, then 4, and then 5. Let me write it below so that we can understand it better. Let's say that if we have been given 1 is connected to 2, then 2 to 3, then this, then 4 and 5, like this, right? If we have been given this particular binary tree, then we have to print the post order traversal for this. What is post order traversal? Post order traversal, hi Yash Bansal. Post order traversal is nothing but it is left. You first of all traverse the left, then the right, and then the root. This is how the post order traversal looks like, right? So what you will be doing in this particular thing is you have this particular tree right with you, so you will be at the root. So let's check out what will the post order traversal first of all. So you will be moving down because you will be at the current node, right? You will be at the current node, so this is the root node currently, so you will be at it, and first of all you will traverse towards the left. So you move towards the left, you have moved here. Then what you will do, this is your current route now, this is your current node. For this also you will check out the left, so you will go to the left, and what is at the left? The left is 4. Does this left have a node 4 have a left or a right? No, it does not have a left, so you will not write anything on the left. Does it have a right? Yes, no, it does not have a right. Does it have a root? Yes, it is all itself a root, so that's why you will write 4, right? Right after this, what will happen? This part is done, this much traversal is done. Then what is the thing? For after left you have the right. So for this particular node, the left was 4, so the right will be 5. So you'll say okay, 5 is the next node in the line. Then after that, this node itself, that is the root you will be writing, so you'll write the root. So the root is nothing but 2. Now this much traversal is done, right? This much part of the traversal is done. So what will you do next? What will you do next, right? What will you do next? Next step, what you will do is you will again move back to this particular parent, right? Because this particular parent, that is once left has been done, once left has been traversed. Now for this you will traverse on the right. You will traverse on the right. You find this 3. Does this 3 have a left? No. Does this 3 have a right? No. Does this 3 have a root? Yes, it is itself the root, right? So that's why you'll write 3. After that, what will happen? After that, for this particular node 1, its root has also been, its left has also been traversed and the right has also been traversed, so the root is left, so you'll write 1. So that means 4, 5, 2, 3 and 1. Let's check out the answer. So the answer you can see for 1, 2, 3, 4, 5, this particular tree, the answer is 4, 5, 2, 3, 1, and that is what we are also getting. 4, 5, 3, 2, 1. Is the post order traversal clear to everyone? If it is clear to everyone, please give me a +1 in the chat. Please consider giving me a quick +1 in the chat and like the video if this much part of the problem is clear to everyone, and then so that we can move ahead with the problem, right? You can give me a +1 in the chat a little quick so that we can move forward. Like this will be the post order traversal of this particular binary tree, right? Let's take another case if there is given. So let's take this particular case, 8, 1, 5. If I will even take this case, so for any case that I will be taking, this will be the thing, right? what you will be doing is, like, if I take any case, let's suppose that I take this case, the very basic case, that is 1 is connected to 2 is connected to 3, something like this. If I take this particular case, then what will happen? I need to print first of all the left, and then I need to print the right, and then I print the root. This is the way that I do it. How? I'll be at this particular node, so I'll move towards its left, so the left is 2. Then for this particular node, I'll move towards its right, so the right is 3. Then for this particular node, the root itself is 1, so I'll print 1. So this will be the post-order traversal, right? Now, if I was using a recursive approach, right? If I was doing recursion, so it could have been very easy for me. If I was doing the recursion part, if I was doing this recursively, then it would have been very easy for me. How it could have been easy? Because what you have to do with recursion, you just have to write some conditions, right? You have to check in the recursion that if the root is null, then you return from that particular node. Otherwise, what you will do, you will first of all call the left, then you will call the right. So you call for the left, right? You do something like this. Let's say this was a DFS function that you had, something, or let's say this was a pre-order function, post-order function that you had. So what you will be doing is, let's say I name the post-order function as post, right? So this is the function that you had, in which you had the root. So what you would have done is, you would have called the post-order for the first of all root. So you would have called it for the left, right, for the left of the root. Then you would have called the post-order function for the right of the root, and then you could have simply printed, let's say you could have printed the current node, that is the root. Could have printed the root. This way you could have done it using the post-order traversal if the recursive approach was applicable. If you were allowed to do it recursively, then this is the way that you could have done. But here you cannot do it recursively. You have to do this iteratively. So how will you do this? If you know that if you are applying a post-order traversal, or if you are applying a recursive approach, so that is basically done using the concept of nothing but stacks, right? Recursion is implemented using the concept of stacks. So here we can use stack, right? Here we can use stack, but we will do it iteratively. So what I will do is, let's say I have this particular tree, that is 1 is connected to 2 is connected to 3. I'll come to the bigger example, but let's understand from the smaller examples first, so that we can build upon it, right? What I want to say is, if I have this particular tree, that is 1, 2 and 3. So what I'll do with this is, first of all, in my stack, what I'll do is, I will insert 1, right? I hope that you know that you run until the queue is empty and things like these, right? What I will do is, in my stack, I'll first of all have 1, right? So I'll say okay. I'll also have a resultant vector which will be storing all the nodes in the post-order traversal, right? Yash, Bansal and others, is it clear to everyone? Right, so I'll push 1, and I'll pop this 1 out once I get into the loop, right? Once I get into the BFS traversal, then I'll take its left, and then I'll take its right. So the right is 3, like this, right? This is what I would do. Now, does this seem optimal? Let's see. Now you will have 3, so you'll take out 3, 3 does not have any child or something like that, so you will put 3 here. Then you will have 2 left, because 3 would be taken out, so 2 left, so you'll take 2 out. Now, does this look like a post-order traversal? No, it doesn't. But what is the actual post-order traversal for this particular tree? The actual post-order traversal is nothing but the left, then the right, and then the root. So what is the left? Left is 2, right is 3, and the root is 1. If I just reverse this, the below given vector that I have, if I just reverse this vector, will I get the post-order traversal? Yes, I will get it. I'll get 2, 3, 1. And that is nothing but the post-order traversal. Does that make sense? Maybe it doesn't. Let's check out for the bigger test case, so that we can be much clear with it. We can be much more clear with it, right? So let's take a bigger test case for us. So let's say if this was 1 was connected to 2, then this was 3, then this was 4, and this was 5. If the tree was like this, if up till now everything is clear to you guys, so you can like the video and you can give me a +1 in the chat for acknowledgement purpose, right? What I want to say is, now I'll again have the stack. First of all, I'll insert 1, that's perfectly fine. I'll have a vector of answers in which I'll be storing all the nodes that I'll be having. So first of all, what I'll have, I'll store 1, and I'll pop out 1, and from the current root, I'll move towards its left. I'll first of all push the left node and then the right node. So I'll push 2, and then I'll push 3. I'll say okay, this much part is done. Then what will happen? What will happen with this part? Anyone can tell me? Anyone can tell me what will happen after this? All of you can just like the video, hit the like button, please. Okay, what will happen? After 1, I'll be pushing what? I'll be pushing 2 and 3. in my stack after I've pushed 1, so I'll be having 2 and 3, right? This is what I would be having. I would be having nothing but 2 and 3, right? Now which is the topmost element? The topmost element is 3, so I'll take out 3 and I'll write it here. I take out 3, I simply write it here. What happens next? Also, what happens next after I take out 3? So I'll put its child inside, I'll put its children. So there is no children of 3, so that's why I'll put nothing. Then I'll take out 2, and I'll put its children. So the children of 2 are nothing but 4 and 5. So first of all 4 will be here and then 5 will be here, right? So what happens? I pop out. So 5 comes first, then 4 will come, right? So this is the order. This is the answer vector that I am getting. Let me see what will happen if I do the post-order traversal. So according to the post-order traversal, the very first node should be 4, then it should be 5, then it should be 2, then it should be 3, and then it should be 1. Now understand the similarities between this and this. Between this and this. Can I say if I reverse this, so this will be nothing but 4, 5, 2, 3 and 1, and I would get it. If I just reverse the answer vector, I'll get this answer. Can I say this? Can I say this? Now let me show you what I'm saying, what I'm actually saying. Let me show you the code part for that. What I'm saying is I have a vector answer in which I'll be storing the data of all the nodes, right? What I'm saying is I'll have a stack which will store all the nodes. First of all, I'll put the starting node that has been given to you, the root node that I have, right? Then what I'll do is I'll iterate until the queue is empty. This is the iterative stack traversal that I am doing. Now what I'll do is I'll take out the current node, right? Current node. So what will happen? I'll take out the current node and I'll pop it out. I'll pop it out from the stack, and then I'll simply push it into my answer as I told you, right? I'll take out the node, I'll pop it out of the stack. I push back into my answer vector, right? I push its data into my answer vector. What I'll do next? I'll check if its left child is existing. If its left child is existing, then in that case I'll push its left child into the stack. If its right child is existing, then in that case I'll push its right child into the stack, right? And in the end, I'm saying that once this traversal is over, so you will have a vector that will store the reverse post order traversal. So you just do this, that is, you just reverse the answer vector and you will get the post order traversal iteratively. Does this make sense? Is this much part clear to everybody? Please let me know in the chat. Please let me know, and then only then I'll be able to proceed further. Does this make sense? Does this approach make sense to all of you? Please give me a +1 in the chat. A quick +1 in the chat would help from your side, right? What I'm saying is I have a vector answer, I have a stack st, right? I push the first node that's been given to me, I push it into the stack, I run it until the stack is empty, I take out the topmost node, from the stack, and stack works on the concept of last in first out, okay? I push the answer into from my temp, right? I push the answer, and then what I do is I check that what is the left existing for that particular current node. If it is existing, so I'll push it into the stack. If its right child is existing, so I push its right child into the stack, and then this would work until the stack is empty, and simply in the end I'll just reverse the answer because it is storing the reverse pre-order, right? Does this make sense? Please give me a +1 in the chat, and please like the video if this much part is clear to everyone, right? I hope that it is clear to everyone. Now another way to do it could be like this. Let's say you do it another way. What is another way? Like a similar way but without reversing. Like reversing the vector does not seem much good, right? You will say that okay, it's good that we are able to solve the problem, but maybe reversing the vector is something that doesn't make sense to you, right? So what I'll say is we can have another approach for it as well. Please give me a +1 in the chat and like the video as well, right? Let's say I have 1, 2, 3, 4 and 5. If I have these things present with me, what I could do is I have this, I'll have my stack as well, so I'll say okay, I have my stack as well. Then what I'll do, I'll first of all push 1, so I'll say okay, and I will be having an answer vector, right? I'll be having an answer vector. So what I'll do is this time around I'll fluctuate my answer vector in such a way that I'll be doing it optimally. How? First of all, I'll push 1, right? I'll push 1 into my answer vector, and what I'll do is I'll take out 1. Then from 1 the children that we get is 2 and 3, so I'll push 2 and then I'll push 3, right? I push 2 and 3. Then what I'll do, I'll pop out 3. Now I'll pop out 3. Once I pop out 3, so instead of pushing this 3 here, instead of putting this 3 here, I'll put this 3 at this particular position. Instead of putting this 3 here, I'll put this 3 here. Before at the very start, I'll put every node that I take out from the stack at the very beginning of this particular answer vector. So what will happen, this 3 will come here, so this 3 gets popped out, and earlier I was doing 1 and 3, now I am doing 3 and 1, right? Now I'm first of all, whatever node I'm getting, I'm inserting it at the beginning, right, in the vector. This is what I'm doing. So I have 3 and 1. Then what happens? I have 2. For 2, I'll take out 2. Earlier what I was doing was I was inserting this 2 at the back. I was pushing this 2 back, so this would look like this. But now I am not doing this. Now I'm not going to do this. What I'm going to do is I'm going to push this 2 at the very starting. I'll push this 2 here. I'll push this 2 here. Right. This is what I want to do. Why I'll let you know. So this would become 2. I'll say okay, this becomes 2. Then from 2 I have the children 4 and 5. So I'll say okay. One child is 4, another child is 5. So I'll say okay. Earlier also what I was doing, I had a particular top node. I was pushing it at the back. Right. But this time I will not do this. What I'll do is I'll have this 5 and I'll push it at the very beginning. I'll insert it at the very beginning of the vector. So what does it become? It becomes 5. 5 comes here. Then what will happen? This 5 gets popped out. After this 4 is there. This 4, ideally I was previously I was inserting it at the back, but now I'll not insert it at the back, right? I'll not insert it at the back. What I'll do is, instead of inserting it at the back, instead of inserting every top node at the back, I am inserting it at the very beginning. So this 4 comes here and this 4 would be here, right? So does this seems to be post-order traversal? Yes, it does. Why? Let's try to do it. So what is the post-order traversal? Post-order traversal is nothing but left, then right, and then root, right? Left, right, and root. Post-order traversal is this. What I am doing is, first of all, I have the particular given left, right? I have the node. For this node, what's the left? The left is 2. For this particular, if this is the root, then its left is 4. So left is 4. Then for this particular root, I have 5. 5 is the right. Then I will write 2. Then I will write 3. And then I'll write 1. So this would be the post-order traversal if I was doing a DFS, right? And this is the post-order traversal that should ideally be there. And you can also observe that this post-order traversal that I'm getting by inserting every top element at the beginning, this is also I'm getting, and this is also the post-order traversal, right? This is also the post-order traversal that I'm getting into my answer vector, right? So what I'm doing basically is, I'll show you the code for that. What I'm doing is I'm again declaring a stack answer vector, and I'm having a stack in which I'll be storing all the nodes. So I'm pushing back the node, starting node. What I'm doing is I have the node, I've stored the temp, I've stored the current topmost element of the stack. I've popped it out, and what I do is, instead of inserting every current top, every temp, instead of temp is storing the top. So instead of storing every top at the end, I'm inserting it in my vector, I'm inserting it at the beginning. In the vector, I'm inserting it at the beginning. So that's why in the end, I will never have to reverse my vector, right? That's what will happen. So this will be the optimal, like this is the approach that will give me the post-order traversal without even reversing the array vector, right, or the list. So if the left is existing, so I'll push back the left into my stack. If the right is existing, if the right child is existing, I'll push back the right into my stack, and in the end I'll just simply return the answer vector. Is this part clear to everyone? Hi Aryan, is this part clear to everyone? Please give me a +1 in the chat. Is this approach clear to everyone? Is it clear to everyone? Previously this problem has been asked primarily in Microsoft. So I'm here for 60 seconds more. If you want to ask anything, you can ask. Otherwise, we can end this stream, right? Is the problem clear to everyone? Like how we are doing it using just one stack. We are doing it like how we are doing it. And these are the two most optimal ways to do it. So if it is clear, please write clear in the chats in the end so that I can be assured that you are well clear with this example, right? Anushka, you were clear with it? Please write clear in the chat if you were clear, right? I hope that you people were clear with it, right? This is the optimal way. Using one stack, I told you two ways to do it. Either you just pop whatever top element you have in the stack, you just push it in the last and at the end of the vector, or what you do is you insert it at the starting. If you will push it at the back, then in that case, in the end you'll need to reverse it, and this does not seem optimal. This does not seem that good, right? But you can also do one thing, that instead of inserting at the back, you can insert it at the beginning, right? So that is also something that you can do. So this was the problem. It was asked in Microsoft. So today's problem of the day that we have is find prime numbers in a given range. Previously this problem has been asked in VMware, Qualcomm and GE, so you can try to solve this problem. Make sure after this you have completed this particular problem, you can come back to this video, the problem of the day today if you have completed, so you can come back to this video and you can let me know like how you did it, things like that. I'll be reading your comments in this particular video description, in the particular video after this video is over. Thanks a lot for watching everyone. I'll see you soon in the next live.